Hey guys. Morning Azra, morning John, morning Eric, morning Logan, morning Hayden. How you doing, Hike? Hey Rainey. I'm sure Miss Mikett will show her when she's ready. Show him when she's ready. Hi Charlie. Hope you guys are doing good. You had a good weekend. So, the agenda right now for today is doing DNA number 1. We're back to DNA sheets. DNA question to start each day. You'll answer that on your sheet, which is under classwork and references. This is week 23. We skipped 2 weeks because of the unit test, 1 week to prep, and then the unit test itself, which was last week. All right. So we're back to DNA sheets. We're back to answering a DNA question. I would start by answering that question right now. I'll go over it in a few minutes. All right. As I get through the intro. After we do our DNA sheet, I'm going to introduce to you tour of the solar system. Being able to pick out a planet, do a little bit of research, provide us a background on that planet, why it's important in studying our solar system, and then being able to present that information. How are we going to do a presentation? Well, you're not going to film your face, but hopefully you'll be able to film some slides you'll make through Screencastify with your voice over it. If you can't use your Chromebook or Screencastify, that sounds way beyond what you can do. One, I'll help you first, try and figure it out. And second, you can just write a CER, all right, or a little essay response, just to kind of give us an explanation of what the slides are, what you're trying to show us. All right, there are a couple of limits. You're not doing Pluto. You can do planet number 7, all right, but we can't have everybody doing the same planets because my goal is to have, the best in each planet, kind of a reference for people, all right, as we move forward. So I'll talk more about that in a little bit after we go over our DNA question. DNA sheets are due Wednesday at midnight over here in the upper left corner, covered by the agenda. You can see the agenda right there. Let me move it. Due Wednesday before midnight. That's because we do have a shortened week again. Well, for you guys, teachers are in school on Friday. You guys will not be in school. Nothing new, but if you are missing stuff, absolutely, I'd be working on stuff that you're missing. All right. Also, there is no due date for a tour of the solar system right now. My goal is to have a tour of the solar system due early next week, Monday or Tuesday. Depends on how these next couple of days go, how difficult research is, because we haven't done that in a while. And also, with this storm, like Eric said, he got a tree down in his yard. People out in Western Coventry or people even towards West Warwick, one way or another, you're probably going to run into an issue with power with this storm supposedly. Around 1 o'clock, wind's going to pick up, cause some damage. So if you lose power, don't freak out. Might make an even more stir-crazy situation inside your house worse, but we'll just work when we can, all right? Speaking of that, though, I would make sure your phone's on a charger for a good long while. You want to keep things charged up as best you can, all right? Find a good book, all right? Hey, Ryan. So you can click on these two postings here in Classroom. They're automatic when I post something, or you can just remember where things are under classwork, top tab, new section. universe, galaxy, and the solar system. I'm not going to call it UGSS all the time, but just know if you see UGSS, I'm just writing that instead of this whole long thing out. To where the solar system is the first thing there. All the way at the bottom, Sun, Earth, Moon system is down there, and then things from earlier in the year. All right. References, your key term guide's been there. Science Weekly sheets, the old ones are there. But the DNA sheet is what you're interested in, number 23. Open that up. I already have it open. Try to color code it. You do blue. Do not forget to do blue this week on Wednesday. People forgot to do blue last time and they lost a point. Don't have that happen. If I agree with you, I'll add G-Bucks in there and tally them for you. All right. You are answering in 1, 2, 3, or 4. Today's number 1. And if we need more information, obviously, online science notebook. You can put your cursor in here. You can hit tab to make a new row, or you just hit enter to make the spacing bigger. So that's for you to use extra space. All right. So you're answering the DNA question right here, or you should have been. What is a light year and how far is it in kilometers? This comes from Bill Nye back on Wednesday of last week. Bill Nye and your unit test grades are in Aspen. What I returned to you last week, which a couple people got scared of, and I warned you in a message saying this was not the accurate score, people saw that they got like a 16 out of 32, they got a 15 out of 32, they got a 12 out of 32. Remember that number, 12, 16, 15, was out of 16 multiple choice questions. So it was going to look bad, but you had to check Aspen for your final score because your justification was not graded by the Google form itself. Okay? I went through and graded justification, most of which were good. You didn't really lose too many points on. All right? Even if you got the question wrong, I was still looking at your thought process. You did not get a 31 out of 100. It's out of 32 points. Any last questions, concerns before we start talking about the DNA? So like I said, make sure your phone's on a charger, iPad's on a charger, whatever's on a charger. Eric said make sure your Chromebook's on a charger. I should have said that. Make sure your Chromebook's on your charger. I post. See, you guys don't read. You don't read. The message said check Aspen. I knew it was gonna freak people out. I shouldn't have released it. Should just said check Aspen. But I did want you to see which multiple choice ones you got wrong. All right. DNA. What is a light year and how far is it in kilometers? Let's pull up the whiteboard. Anybody want to guess what a light year is before I can write it? That is way too much, Jake, but I like the idea. Go big. Nice job, Hike. Hike's on fire. Distance light can travel in 1 Earth year. It's about 9 trillion. We're going to go with 9.5 trillion kilometers. All right. 540 trillion kilometers. I think you got that number from the last question, Bill Nye. How far has light from your screen traveled in space? since the beginning of the episode started, about a 20-some minute episode. It was 540 million kilometers. So million, billion, trillion. See, this is why I'm going over this question today, because these numbers are so large, and they all kind of sound similar. I'm using light year to kind of introduce to you guys the idea of scientific notation. How can you make large numbers appear small so you don't get confused always on also million, billion, and trillion, or even quadrillion? All right. So light year, like Hike has said, the distance light can travel in one Earth year. So 365 and a quarter days. Easiest way to define it. I wasn't even going to say Earth. That's a good way to differentiate Hike. So good addition. All right. Distance light can travel in 1 year. And this is also in a vacuum. So it's not through air, it's not through water, it's not through glass. It's through a vacuum where no other atoms or molecules or compounds can interact with it. Is empty space actually completely 100% empty? No. There is a lot of diffuse gas in empty space. There are particles popping in and out of existence in outer space. So light can still interact with things, plenty of things in space, but a lot of space is empty, and so light can travel its fastest usually in that empty vacuum. All right, the nothingness of space. How far it can go in 1 year. How far is that? It is 9.5 trillion kilometers. If matter and antimatter touch, because they have opposite charges, and it's the only real difference between matter and antimatter, you're going to have both annihilate each other into pure energy, because mass can be energy and energy can be mass. So you convert all that mass, all that matter and antimatter into pure energy. And that energy could, in theory, reform itself back into particles and then eventually back to matter. It's just a pure exchange. In any chemical reaction like combustion, you don't have a pure exchange from matter to energy. You break bonds in combustion. You actually break matter in antimatter and matter collisions. But the universe, as we're going to talk after the solar system, guys are always jumping ahead, which is good. The universe has a bias towards matter instead of antimatter, which means the universe tries to make more matter than antimatter. Why? Is ongoing research by physicists and astronomers. Because if they're both the same thing, roughly, it's just except opposite charges, should be equal amounts of both. But there isn't. That's why you're here. Well, one of the reasons. All right. So light year distance light can travel in 1 year. It's about 9.5 trillion kilometers. How many zeros is a trillion? So this is a little bit about scientific notation. All right. Scientific notation is a way to write large numbers more simply, or it's also a way we can kind of do a little bit of math. All right. If you saw my Why Does the Sun Have a Shadow, which we're going to watch as a class, part of a class assignment after Tour of the Solar System, I use scientific notation to cancel out exponents. All right. So, what's 9.5 trillion? Well, here's 9 and here's 5. Okay. Add a 0. There you go. Yep, you guys are adding it in. Is it 9 zeros? Be careful. There's 950. Add another 0. There's 9,500. You add another 0. Now we have 95,000. Add another 0. Now we got 950, 100,000. Add another one. There's 9 million. $95 million. 950 million. There's your billion. That's a billion. So how many zeros we have now? 1, 2, 3, 4, 5, 6, 7, 8. We have 8 zeros. All right, really 9 spots past the 9. We're including that 5. All right. Oops, I lost a 0. Add another one. Now we're at... oh, yeah, off by a little factor, huh? Now we're at 95 billion. 950 billion. Let me get rid of these commas. And then the last 0, we should now be at a trillion. Let's see. Comma, comma. Oops, am I off? 4 zeros. There. There is your 9.5 trillion. All right. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 zeros. 11 zeros. Followed by 5. So if you include 5 and those zeros, you got 12 spots past that 9. So trillion is a factor of 12, right? There's 12 spots behind that trillion. Brain hurts. See, this is why we use scientific notation. See, you don't understand, but this 9.5 right now is actually in scientific notation. It's a smaller number. We just use trillion instead of writing out all those zeros, all right? So, but why I'm doing this is because you're going to start seeing very large numbers. You're going to see planets with masses in the trillion. You're going to see radii and millions or billions of kilometers. Okay, you're going to see, not really going to talk light years yet. That'll be after the solar system. Our solar system is about a little more than a light year, but you're going to see these large numbers, and we got to understand what these large numbers mean as best we can to be able to use them, all right, in your research. So this is why I'm doing this question. So a better way to write this, okay, is using the zeros, counting up the spots, and then make it times 10. Because zeros, what times 10? You times 0, all right? So here's a decimal spot, right? Like this is 9.5 trillion, 0.0, right? Think of it that way. How many spots? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So if I move this decimal place 12 spots to the left, I can get 9.5. So I can write it as 9.5. But I moved the decimal place that many times, 12 spots, right? So I can put times 10 to the 12th power. So it's 10 times itself 12 times. And that's how you get those 12 zeros, right? Because 10 times 10 is 100. Right? What's 10 times 100? You add a 0 to it, right? It's 1,000. So scientific notation uses powers of 10 to write big numbers smaller. What's 10 times 1,000? 10,000, right? So you do this 1, 2, 3, do this 9 more times, all right? these are equal. 9.5 times 10 to the 12 km is equal to 9.5 trillion. All right. So if you see 10 to the 12, it's trillion. If you see 10 to the 9, like a couple of you thought, that's a billion. All right. Factor of 6 is a million. So it's just how much you can move the decimal place. All right. And for the sake of simplicity, I would stay at this 1/10 spot in scientific notation, even though it's not really a tenth. It's 500 billion, which is half of a trillion, right? Any questions on that? So it's not, it's kind of an abstract thought process, but mathematically it's not hard to do. Just move the decimal place back and forth. You could move the decimal place the opposite direction, but you'd be using negative powers of 10. Negative means go to the right, positive means go to the left. Why is light so fast? Or why does light have its speed limit that it does? 300,000 kilometers a second? I don't know, Hayden. It's a good question. Why is light so fast? Well, it's almost pure energy. Why does it have its speed limit? Why can't it go faster? Is a good question, too. I'd have to look into it. So here's your DNA. I added scientific notation to it as extra information. Make sure you include that just to understand, because we're going to use this going forward. And I'm going to ask you a question about scientific notation tomorrow. All right? Using how can you convert one to another. All right? Is the expansion of the universe faster than light? Yes. Like, it is. And why is, again, another debate in physics and astronomy. How can the universe be expanding faster than light? Well, we are looking at something called dark energy, which is causing things to expand faster than light for some reason that we have to look at. We don't understand what it is, so we call it dark. All right, so that's another great question. Don't know what it is yet. We don't know if it is some kind of repulsive gravity. We don't know if it is due to cosmic inflation in the very beginning part of the universe, like in the first seconds of the universe. Don't know if it's some kind of constant. Einstein thought it was a constant. Some physicists thought it was due to this outside force, this other fundamental force that we have not looked at yet. So there's lots of different solutions to this problem. But yeah, eventually there is something called the observable universe, and there's something called the universe. You can only see so many light years in one direction, or any direction. There's a universe beyond the light year that you can see because they're expanding faster than you can have a light ray reach from a star. So yes, the distances are getting so large that over time, that light beam from a star past the observable universe will not reach Earth ever, because the universe is expanding faster than light can travel in. It's very mind-boggling. Eventually, yes, that's the idea. Galaxies will kind of be their own islands. They'll be their own observable universe. Yep. No, not during your lifetime. We're talking trillions of years upon trillions of years. We're talking magnitude of powers of 10 by like unimaginable numbers. Like 10 to the almost not infinity, but very large numbers. And then you're not going to have, obviously, stars fusing elements together. You're not going to have star formation anymore. Everything will either be a neutron star or a dwarf or a black hole. Eventually the black holes will dominate, and then you'll just have black holes left over. And the black holes will either evaporate away due to Hawking radiation, or they're going to merge together, and you're just going to have nothingness at the end. Is there be a new Big Bang? How do you get a new Big Bang out of quantum mechanics? It's another cool field of research in theoretical physics. So we're going beyond Sun, Earth, Moon. Right now, I just want to talk about the solar system. It's great questions to have about the universe. That's fantastic. We'll get more into those as we go. All right. Even talk a little bit about gravity waves. I had a lab that we were going to do in school about looking at gravity waves, how you can model them. Might have to be more of like a demonstration. All right. So that was your DNA question. Talk a little about tour of the solar system. And then we'll get into you doing some research if you got any questions. You have to define what smarter is, Charlie. Smarts and intelligence. Is it hard work? Is it just innate ability? Is someone who just gets something right all the time but doesn't put any hard work in actually smart? That's how you define it. All right. So tour of the solar system is here, or you can go under classwork, like I showed before, under Universe, Galaxy, and Solar System. You're going to click it. Open up the document. All right. Tour of the solar system. You are going to choose a planet in the solar system to research further, except Earth. We've done Earth. We've done everything about Earth except the interior of the Earth. So avoid it. All right. I want you to expand your horizon, literally. And any dwarf planets. All right. Which means the most famous one, Pluto. You're not doing it. I'm going to use Pluto and the other dwarf planets as part of discussion next week through our DNAs. All right. So I want to avoid that for a later time. With the information you gather, you research, you're going to create slides and film yourself presenting them from your Chromebook. I don't need your face on there. All right, that's Miss Kilduff, good. Or write a CER report on your planet. So if you can't figure out Screencastify, you don't know how to record your screen, you share your slides with me and you do a little write-up. All right? But if you can, great. I'll listen to you. I'll watch you present your slides. And then I'll make a little resource of all the plants people researched. I'm hoping we keep it a little balanced. I'm going to let you pick. I'm not going to try and limit you, but I don't want everybody doing planet number 7. I don't want everybody doing, trying to think what else would be another popular one. I don't want everybody doing Jupiter. All right, I want you to pick what you want to do, but hopefully it stays relatively even. Your presentation should be in regards to the prompt below in red. Okay, the table at the end will help you look for information, break it down to topics. Information needs to come from sources that are accurate and reliable. That means websites that end in .gov, .org, .edu. Some .coms are okay. I'm going to show you an example of that in a second. Wikipedia is a good place to start, but is not a source. I'll show you how to use Wikipedia as a good place to start, but not as a source. Okay? So a couple things after I go through this. It does, however, have potential accurate and reliable sources in their notes. So we'll show you where those notes are. Google itself is a search tool and not a source. I'll show you again that. You can't use Google as a source because Google is a search tool, it's a search engine. When it gives you a little blurb that's an answer, that blurb has a blue link under it. That is the source that it's showing you. You can only use the same source up to 3 times. What does that mean? That means in this chart down here, little table, the same internet link can only pop up 3 times in these boxes. That's it. Okay? So accurate, reliable sources, I'll show you what's good, what isn't. Can only use the same source up to 3 times. All right. In 2000, and this is all based on in 2006, the International Astronomical Union (IAU) defined a planet with the following 3 criteria: object must orbit the sun, object must be spherical due to its own gravity, and object must have cleared its neighborhood around the sun or other objects. All right. Using those 3 criteria, present your planet as a planet, but also as a unique and valuable object of study in planetary science, not just astronomy, but planetary science, which is like geology, but on different planets. Okay. Insert screencast a slide presentation or defend your planet. So what I linked there is just Screencastify. It's an extension to Chrome. It's free. You add it in, and it'll help you record your slides. Obviously, I'll show you how to do that once we get to that point. All right. But you need to kind of think about a planet, and you need to think about how you're going to conduct this research. The research before you pick a planet. All right. So .gov.org.edu. I think one of the best ones, solarsystem.nasa.gov. You just Google planet and NASA, and you'll come up to this link. All right. I'll probably include it if you want it in Classroom. What I kind of like is they include the solar system as a snapshot of all the planets. You can click on the planets, and you can also see other objects, like other dwarf planets and large asteroids. All right. Bennu, Eros, Ceres, Psyche, those are large asteroids. One of those is a dwarf planet, and you can kind of see and click on each of these planets. That's the inner solar system. The asteroid belt surrounds the inner solar system. And then we have the outer solar system, which is much, much larger. Jupiter, Saturn, Uranus, Neptune. Halley's Comet is on its kind of peak of its turning point, coming back to the inner solar system later in about another 50 years, I think. And then as you zoom out, you start getting into this region called the Kuiper Belt. Okay, we have Pluto, Makemake, Haumea. Eris is out there somewhere. Voyager 1 and Voyager 2, I didn't know that was on that map. Pioneer 10 and 11, those are probes from the 70s. New Horizons was a probe that went past Pluto in 2006, 2007, or was launched. I can't remember that time frame. But you can see there's other objects in our solar system besides planets. Okay, dwarf planets, asteroids, comets, and even man-made objects, human-made objects, probes, missions. And that's going to be part of your research. All right, so this is going to be a great resource for you to take a look at, and you can kind of see other news and destinations. All right, some .coms are good. They are accurate, reliable sources of information. Some news websites are okay. BBC, CNN, National Geographic, okay, natgeo.com, nationalgeographic.com. They do have a solar system reference. All right, you can take a look, click around, look at the different planets. All right, so those are just examples. Government.gov.edu, some .coms. If you have a question about a .com, let me know. All right, but obviously you're not going to go to ilikeplanets.com or ilikeplanets.blogspot.com. All right, so those are 2 examples. How about if I just Google Earth? Let me use one of the research topics. So, distance from the sun. So I just Google distance of the Earth from the sun. And I get this little blurb, right? This blurb is, again, not a source. You can't just take this link, copy and paste it. Google is not a source. Google is a tool. Where's Google pulling 93.222 93 million miles. Again, that's in scientific notation. 93 million miles. It's pulling it from Wikipedia. All right. Wikipedia itself, you can't really use it either, but it does have notes you can use. So Earth orbits the Sun at an average distance of 150 million kilometers. Well, where does Wikipedia get the information from? You see this little note right there, a little number 1. You click number 1, and it brings you to the bottom where all its references are. This is where Wikipedia gets its information from. It gets it from Solar System Exploration, Sun Facts and Figures, from NASA. Oh, that actually just brought me to NASA's page. Click the first link. Hopefully it'll load. Click the first link, and there's that actual source. All right, solarSystemNASA.gov, that planets. So you gotta be careful that this is the same source for you right here, solarSystem.nasa.gov/planets. That's the same source as solarSystem.nasa.gov/planets. So you gotta be careful, okay? You may use Wikipedia to get an idea of where to go, but Wikipedia has sources. It's a tool, just like Google's a tool. All right. So when you're looking up information on Google, keep in mind Google pulls information from other places. It's not a source. Those other places could be Wikipedia. Wikipedia compiles information. It's an encyclopedia, but it pulls that information from other sources too. So your best bet is kind of just going through Google, perusing the links, and then seeing the information that's in them. All right. So that's a little bit about the research. And again, I'll post some of those examples, the Nat Geo, the NASA one, to kind of help you get started. All right. Earth Sky is also another good one. All right. So you'll find others to look at. All right. As we go through the next couple days, if we get stuck, I'll provide a couple more examples. But I think those two, great places to start. This could even kind of help you kind of think about what planet you might want to pick. All right. This one right here. These are all transit shots of the planets, even though you'll never see transits of the outer planets and Mars and yourself on Earth. So on this document, what you need to do today is just kind of start doing your research. Maybe do 1 or 2 of these boxes. All right, you don't have to do them all. There is no due date yet, but I'm hoping your research is done end of the week, end of Thursday. So if we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 boxes, and we got about 4 days, and then you're probably doing 2 to 3 boxes a day. All right. Probably 2 you could finish up on Monday, or you're gonna start working on slides too, so maybe 2 or 3 a day. So maybe these 3, probably a good place to start. Or maybe these 3, surface conditions, landmarks, and interior. All right. I give you an Earth comparison in certain spots. All right. So you can use the Earth comparison. Paste your source in the box. Give me some of the information that you find from your source. Can you copy and paste? You have to put it in quotes. And if you use it later, you're going to have to put it in your own words, obviously, right? But you can copy and paste citations. Mr. G, what happens if we pick a gas planet? What will we describe as the surface conditions? You're going to describe to me, basically, the upper atmosphere. So describe to me, or you can describe to me kind of like what the appearance is of the atmosphere from space, or from the very edge of the atmosphere. Obviously, don't go into the core, things like that. That would be for the later boxes. All right. So just talk about general appearance, conditions, appearance. You'll get more in depth here. Yes, so some boxes apply more to other planets. You're not going to find much for surface conditions for a gas planet, but you're going to find a lot of information about atmosphere, temperature, and weather. Okay. Some of the planets don't really have a lot about atmosphere, temperature, and weather. Mercury as an example. So just how it looks from far away. Yeah, like what features are on there, which kind of also goes into the next box. But yeah, what kind of color? Why does it have that color? Or tell me it's gas. Tell me why it's gas. Why isn't it solid rock? Why can't it be terrestrial? All right. So you'll be picking a planet today. One of 8. We have Mercury right here, Venus, skip Earth. So you got 7 options. Mars, Jupiter, Saturn, Planet 7, and Neptune. All right. So Mercury, Venus, Mars, Jupiter, Saturn, number 7, Neptune. All right. Pick from one of those 7. Do not do Earth, do not do Pluto, do not do other dwarf planets. Do some research, fill in 3 boxes a day. Doesn't matter which 3. If you're stuck, do the first 3, do the next 3, so on and so forth. All right. You can use sources up to 3 times, like this one, in these boxes. So just literally copy and paste them into the box. All right. Questions on that so far? Your rubric for this assignment. There's 6 criteria. It's going to be up to 24 points. Each strand is worth 4 points. There's 6 strands total, 6 criteria. Okay. The first one is geology and meteorology. That means you do research on surface conditions, landmarks, interior, and weather. All right. How in depth you are, and if you hit each of these criteria. All right. This is criteria. Astronomical phenomenon. So I want to know distance from the sun, rotation, revolution, mass, and surface gravity. That deals with the astronomical phenomenon, or just the astronomical nature of that planet. Okay, so from space. This is on the planet. This is from space. Okay, geology, meteorology, on the planet, astronomical phenomenon from space. And then there's miscellaneous research, so things that don't fit into that. I give you some examples as moons, rings, and missions to the planet from Earth. Okay, does your planet have moons? Does your planet have rings? Yes or no? Why? The slides themselves, high level of organization, incorporation of sources per slide, or at the end, gets you 4 points out of 4. All right. Lack of cohesion, lack of theming, no sources, you lose points on your slides. Communication, when you record your voice or your voiceover, or when you are writing a little response about your slides, you're engaging, you're informative. Okay. Vocab, using vocabulary, using the words that you're finding in your research accurately. Okay. So the last 3 deal with the slides and how you present them. The first 3 are the information that you're presenting. So half of it is about content, half of it is about using information and presenting the information. All right. Are these just notes for our presentation, or is this our grade? These are notes, Hike. These are to help you go to drive.google.com and then make a slide. Make like a Google Slides, a slideshow. All right. These should help you make slides. Okay. You can't make good slides if you don't have the notes. So they get graded no matter what, really. And then Eric asked, can we do the Earth? I said a bunch of times, no. Thank you, Jake. No Earth. I provide Earth where it can be compared to by numbers already in the table. All right. So, what you're doing right now, you are picking a planet, put that in, and start researching different aspects of that planet. All right? The moon is not a planet, Eric. It is a moon. It orbits the Earth. You are picking one of the 7 planets. That is not Earth. Jupiter is a planet. You can do Jupiter, Ryan. If what you write in this box is something different than one of these names, you are starting off very, very wrong. Okay? If you are doing something other than these 7 names, you are doing something very, very wrong. I'll help you fix it, but just keep that in mind. Mercury, Venus, Mars, Jupiter, Saturn, Uranus, or Neptune. Don't everybody do Uranus, Uranus, Uranos? There's lots of pronunciations. What's actually the right pronunciation? I got a video I can post later. If you're in chat, though, you want to share it out. Kind of tell us what planet you're doing. Really curious to see. I want to make sure we're not all doing the same thing. Neptune. I know Ryan's probably doing Jupiter. Yep. All right, one repeat isn't bad. Again, if you are also not in the chat, to join it, you would have to use your kind of home email, your personal email, not coventry.net, coventryschools.net. But you can also send through reminder email kind of what you're working on if you're stuck or you have questions. Again, there is no due date yet on your research. I'm seeing how these next couple of days go. If people are having lots of problems, if people are fine where we are, this whole assignment, recording your slides, making slides, all that, sometime next week. All right, the first half of next week. That's the goal. I'll set a definite deadline before the end of the day on Thursday. All right. This little animation, if you've been looking at it, you can set it to solar system or inner solar system. You just kind of get an appreciation for the scale of the solar system. Like Mercury, Mars, Venus, and Earth are all crammed in the inner solar system. And then you got Jupiter, Saturn, Uranus, and Neptune, nice and spaced out. So the distance from the sun basically doubles from Jupiter on. Like the distance from, if you look carefully, distance from the sun to Saturn is half the distance of Uranus to the sun, which again is half the distance from the sun to Neptune. And this is all roughly approximate. So the outer solar system doubles in distance from the sun as you move out. It just makes the solar system much larger than you think. And that just makes it even more mind-boggling when we start talking about galaxies and other stars, other solar systems, and then the observable universe, like we were talking in the beginning part of class today. It's just, space is big. So big. Just like how atoms are so small. They're so mind-bogglingly small. Gonna change to Mars? What's the matter? You don't want to have jokes about your planet constantly? That's why I don't call it that. I call it number 7. Hale-Bopp, famous comet in the 90s. You guys weren't born yet. There's Voyager 1 and Voyager 2. These are the furthest things humans have put into space. They are the 2 probes that did a final tour of the solar system in the 70s and 80s. Big proponent of their launching and their program, Carl Sagan. He pushed NASA and President Reagan at the time to launch these probes to study the final outer planets, because we haven't sent anything to outer planets at that time. And they waited for a perfect alignment. Not a straight line, but almost at like a little bit of an angle, so they could use the gravity of Jupiter to slingshot to Saturn, and then use the gravity of Saturn to slingshot to Uranus, and then slingshot up to Neptune. And then out into outer space, out into the further part of the solar system. So, very important missions. They gave us the first look at the gas giants to try and study the gas giants. And we're finding more and more information. New Horizons passed by Pluto and then looked at a Kuiper Belt object, like an asteroid, further out, finding out Pluto was actually reddish in color. It's not as dull as you would think it would be. That'll be next week. In class, we used to do a debate about Pluto, or about the definitions of planets. This is kind of what this is becoming instead, because we can't really do a debate. No, because we know nothing about it. You know nothing about Uranus? There's some good information. Like, I'm not kidding. They found massive amounts of methane being released on Uranus. One of its moons has pretty unique conditions. It's on its 45-degree tilt, 90-degree tilt on its axis. How did it end up tilted? That's interesting. Too hard? Okay. We do have a lot of information on Mars. We've sent many probes, many missions there. So the more missions, the more information you're going to have. Definitely. Probably the most explored planets you're going to find: Mars, Jupiter, and Saturn. If you're still kind of up in the air on who you want to choose. Mars, Jupiter, and Saturn probably have the most amount of data available to them. But we've sent missions to all the planets. And some dwarf planets now, with Pluto. So there is information there. Voyager 1 has been interstellar since 2012. Still makes contact with its radio dish. It's been on its mission for 42 years. kind of its appearance there. Large antenna, dish pointed back at Earth. Actually passed one of the earlier probes sent to the outer solar system, Pioneer 10 and 11. Has a plasma spectrometer. I'm going to have you guys try and make a homemade spectrometer after this assignment. Analyze light from other stars and other sources. Charged particle measurement, plasma waves experiment, cosmic ray telescope, radio science system. So that spectrometer, plasma waves experiment, and definitely the cosmic ray tool really determined when it reached interstellar space. There's something called the heliosheath, the heliosphere. It's the boundary between our solar system and interstellar space. It's when charged particles coming in from interstellar space meet charged particles leaving our sun. Remember, charged particles are what makes the thermosphere so incredibly hot in the Earth. Nat Geo, I don't know if anybody jumped to Nat Geo. They got a lot of photos. I don't know if they have a lot of information. They were reading on Mercury. Mercury will be deceptively really interesting. People might say it's just hot and dead. Well, it's incredibly, incredibly, incredibly dense. I think it's one of the densest of the planets. I have to double check that, but why is it so dense? What would that mean in its past? I think it would be pretty cool to look at. Mercury is like a hot soup bowl. Yeah, except you can have ice on the day side of Mercury. How is that possible? Because Mercury's atmosphere, it's not very thick, so it doesn't transfer heat by convection very well. And so if you're in the shadow of a crater on the day side, you could have ice form. It's pretty cool. Creating matter on it wouldn't be that difficult. Creating matter on it. It would have a lot of access to the matter that formed the solar system. So maybe it was bigger in its past, is maybe what you're kind of saying, Jake. Some scientists think that. Resembles the Earth? Mercury? I don't know about that. Again, everything's kind of slanted because there is no up or down in space. There we go. Notice how the planets stay on that relatively even tilt, and some of these other objects are kind of lopsided. Ceres goes a little bit above the sun. Right now, Eros is going a little under the sun. So these are all asteroids. To hold the space goop. I don't know about Mercury. I think you have a better case for Venus and Mars. Venus is what happens when you're too hot and you hold all that space goop. Mars is what happens when you're too small and too cold and you can't hold on to that space goop anymore. Space goop, I'm imagining. Water, hydrogen, helium. Amino acids, how did they start? Amino acids help build proteins. Amino acids come from RNA and DNA. How did RNA and DNA start? So this is why I like the solar system, because you can talk about anything. Physics? Sure. Chemistry? Yep. Biology? Absolutely. So if everybody's just kind of researching, no one's got any immediate questions. Again, if you are stuck on something, you can't find a source, you're wondering if the source is allowed, you have a question on the rubric, you have a question about what this chart is for. Should I finish the entire chart in a day? No. Should I finish some of it? Yes. Okay. Do I pick the Earth? No. Do I pick the Moon? No. Do I pick Pluto? No. Do I pick one of these 7 names right here? Yes. Okay. Why is it a planet? Hopefully because it fulfills these 3 criteria. But then if it fulfills those 3 criteria, what else is special about it? Because we're going to look at how Pluto compares and how the Earth compares. All right. Again, ask through email, ask through remind. I'll be posting this with the streams link, the nasa.gov planet overview, Nat Geo. Remember, Wikipedia is not a source. If you post Wikipedia or you post Google as a source, you're going to lose points right here in the slides section because your research isn't exactly accurate, reliable. Will it be right? Probably. But did it come from a source that we always know is accurate, reliable? I don't know. Do we have to list every mission to the planet? And this is key because some planets have a lot of missions. No, Logan, you do not have to list every mission. I would maybe, if there's like a lot of missions spanning a long period of time, I would pick probably the more recent ones, like in the last 20 years or so, if there's any, or some of the more famous ones. So Jupiter's had a lot of missions go to it. I would include Voyager, but then I would also include the recent ones like Galileo. Saturn, same deal. I'd include Voyager, and I'd include Cassini, Huygens, things like that. All right, so include old ones, include current ones. Mars has a lot. Use Vikings as obviously the early ones. Those are the most famous first ones. And then I would also include Spirit, Opportunity, the InSight lander that's in there right now. Maybe the one that NASA and ESA are going to launch this year. Those would be important ones to include. All right. So go like in the last 10 years and the famous ones in the past. If you have questions about specific ones, let me know. You don't have to list every mission. But again, that's good information, so you can include that too. Should we add the first ones? Yeah, Ryan, I would include what the first mission was to that planet, because that would probably be the most famous one. It probably would help scientists try and think of other questions and other missions in the future. All right. Okay. You all good? Email or remind me if you have a question. Again, just focus on maybe the first 3. Don't go any further. All right. Stay safe. Obviously, you can't really go anywhere anyway because of the weather. Oops. But keep things charged because it's going to start getting windy in a couple hours. All right. Hopefully, we'll catch you tomorrow. See you later. Bye, Ryan. Bye, Azra. Bye, Rainy. hike.